In this video, we'd like to talk about limits that involve infinity. So first, let's look at an example. What can we say about this limit, the limit as x goes to 0 of 1 over x squared? Well, let's first graph 1 over x squared. So as we can see, it's not defined at x equals 0, and it's not really approaching any number. So the limit does not exist. However, we notice that as x approaches 0, the value of the function is getting larger and larger. So we would write that the limit as x goes to 0 of 1 over x squared is equal to infinity. Now, keep in mind that infinity is not a number. Writing that this equals infinity is just a notation to describe the behavior of this function as x approaches 0. It's saying that the value gets larger and larger. Now let's take a look at another example. How about the limit as x goes to 0 of 1 over x? Well, let's again graph this. So this time, as x approaches 0, we can't really rate that it goes to infinity because while it is getting larger and larger on this side, it's actually getting more and more negative on this side. So first of all, this limit does not exist. But we have a nice notation when we want to describe things that are happening only from one side. If we want to describe what's happening as x approaches 0 from the right-hand side, well, in this example, we see that it's getting larger and larger. So we would write that this is equal to infinity. That is, this is getting larger and larger. What about from the left-hand side? Well, this is tending towards a more and more negative number. And so we'll write this as that the limit as x goes to 0 from the left of 1 over x is negative infinity. Now let's take a look at this example. So first let's just plug in the numbers. So formally, we'll get 6 divided by 0. Now of course, this is not defined, and in fact, if you have a non-zero number divided by 0, then we can conclude immediately that the limit does not exist. However, when you have a non-zero over a 0, it might be a vertical asymptote. So for this, we'll usually need the one-sided limits, and you would need to determine the sign of this function for values that are close to this number here, in this case 3, and since it's from the right, we'll want to pick numbers that are slightly bigger than 3. So for instance, what is the sign of this function when you plug in x equals 3.1? Well, we can see that this will be positive, and this will be positive because you are subtracting 3 from a number that's bigger than 3. So in total, everything is positive coming from the right, and so we know that this is going to positive infinity. Now what about the limit as x goes to 3 from the left? Well, now we want to plug in numbers that are a little less than 3, like let's say 2.9, or just reason out what the sign would be of this expression. Well, if it's just a little bit less than 3, it doesn't matter. That this, even if it's less than 3, the numerator will still be positive, but the denominator will be negative because you're plugging in a number that's less than 3 and you're subtracting 3. So you get negative. So in total, the whole thing is negative. So this will go to minus infinity. Since the right and the left limits aren't tending to the same infinity, then we can't really say anything about the limit as x goes to 3 without a plus or minus. So the two-sided limit of this expression is nothing, just doesn't exist. Next, we discuss limits at infinity. That is what happens when the value x gets larger and larger. So the notation is something like this. The limit as x goes to infinity of f of x, we say is equal to capital L when the function is approaching a certain value as x gets larger and larger. For example, what is happening to the value of 1 over x as x gets larger and larger? Well, here is the graph of 1 over x. As x gets larger and larger, it gets smaller and smaller. So we would say that this limit is equal to 0. What about this limit? Well, we want to think about what's happening as x gets larger and larger. When x is really, really large, like a million, then subtracting 1 and adding 1 don't really change the value relatively to each other. So you'd imagine that this is going towards 1. Now we can actually show that because we can factor out an x from the numerator and the denominator. Since x is going to infinity, that means x is a positive number, so we can cancel these out in the limit. And when x gets larger and larger, we just said that 1 over x goes to 0. And so we're left with just 1 over 1, so the limit is equal to 1, which we kind of expected. Let's do this example. So you have the limit as x goes to infinity of x cubed plus 2x plus 1 divided by 5x cubed plus 3. Whenever you have these types of polynomials and x is going to infinity, one nice thing you can try is to factor out by the largest degree. So in this case, we'll get this sort of expression. So we factor out x cubed from the numerator and the denominator, which means that they'll cancel out. And then you have a non-zero number divided by x squared, and that's getting bigger and bigger. So a general fact is that if you have the limit as x goes to infinity of a, which is non-zero, divided by x to the n, and n is positive, then this is just 0. Any number where you just divide by a bigger and bigger number will approach 0. It gets smaller and smaller. So these will go to 0. You can cancel these out, so you're left with just 1 over 5 as the limit. Now let's consider this limit. If you plug in infinity, which you can't really do because infinity is not a number, but let's say you do that anyways, then it's not so hard to imagine this is infinity and this is infinity. It's in quotations because this is just nonsense math at this point. But anyways, you can't subtract infinity minus infinity because infinity is not a number. So what we would need to do is do some algebra to change this expression into something that we can compute. Now, whenever you have a square root, then it's always a good idea to multiply by its conjugate. And when we do that, we get t squared plus t minus t squared over this, which is this expression. So we can split this into t times the square root of 1 plus 1 over t plus t, because remember, t squared and square root, well, that becomes t. And we're assuming t is positive. Now we can factor out a t so that we have 1 plus 1 over t plus 1, and then a t and a t. So those cancel because t is positive. And now we can take the limit as t goes to infinity. Well, 1 over t, this goes to 0. And so this will go to 1 over root 1 plus 1 when t goes to infinity. So this limit is equal to 1/2. Now, graphically, this function will be doing whatever it wants. It's not an accurate picture, but my point is that when t goes to infinity, that's talking about what's called the horizontal asymptote. So eventually, this function will start trending towards y equals 1/2. And so that's the graphical interpretation of this limit.